Hello guys and welcome back. It's raining outside, so it's the perfect day to write code. Last time we've printed characters to the screen, and this time we are gonna continue on that and implement a simple console that we can log stuff into. We'll also try to implement a very simple printf function that has the basic functionality that we are going to need to basically debug and follow through the execution of our code. So let's get to it. So this is where we've left it last time. We've printed all the characters that we have in our font. And what we're going to do today is we're going to take that and step it up a notch to be able to handle special characters, first of all, such as carriage returns and tabs. And yeah, we'll see where we go from there. So let's get into it. So here I'm going to add a new function, which I'll call, we just call it print. And it's going to take just a car string, right? A car pointer. And what I'll do is I will also just get rid of this this method here, this function here. I'll also get rid of the fill method. Right, so let's get into here. I'll keep the fill method here, and I'll just add inline keyword to print chars so that we can actually inline it. Chances are we are going to have to remove or basically not use this print char because we want to not do all this referencing of framebuffer, font, and glyphs on every single character, which would be horrible for performance. But we'll see when we get there. So let's create our function. We've called it print, and it takes a car star. We call stir, and let's see what we need here. So first of all, we need some basic cursor management, right? So what I'm gonna do is I am going to go up here and create so a U32, I guess I'd call it, and I'll call this column, and I'll init it to 0, and then I'll create a second U32, which I'll call line, and it should be also, should also be 0. So these two global variables will actually be our cursor on the console. Right, so now let's start doing the actual work. First thing we want to do is we want to loop over the stir, so while stir. And since we actually are getting past a pointer, we would probably just create our own so that we can increment it without changing the pointer to stir. So let's do that. So I guess we could create a car pointer called s, and that would be equal to stir. So here, while s, or maybe we should dereference it. So while star s, this basically will stop the loop when we hit the null character, which is the standard string termination sentinel, I guess, in Zig lingo. Right, so here what we need to do is first, let's block in what we want to do with some comments. So first of all, handle, what should I call these special characters? carriage return and tab, for example. So once we have those handled, then we can go ahead and print the character to screen. Right. So these are the two things we'll need to do. And at the very end, of course, we're just going to do S++, so that we move on to the next character. So this is basically how our loop will look like. And we would also actually, let's just block this in. So we would also move on to the next column, right? Because we've written our character here. So we need to move on to the next column. Right, so let's do this then. So if S is either, so what character should we manage here? Maybe carriage return and let's see. Okay, so there is a special sequence on Windows-based computers, which is basically the carriage return and the line feed. So what we're going to do is we're going to handle that first. So if we have a carriage return and we have S+1, which is the next character being the line feed, right? What we want to do is we just want to advance the, so hold on, let me just put it here. So S++, this would basically make it so that we ignore the carriage return and just handle the new line. Yeah, so let's continue on then. There's also something we need to check. So hold on, let's do this. Actually, it should be done here. If the character is not in the font map, glyph map, right? So there might be characters that we need to print that aren't in our glyph, in our font glyphs. So in that case, we would just need to skip over it and not print it, right? So we need to do that check hit there. But I guess for now, we could just... actually, it doesn't really hurt to do the check right now, right? So let's take the character that we want to print, and that be just the reference in the C. The string that we have, and we are going to do if C is above 0, right? Or yeah, if it's less than or equal to 0. And it should be less than font. Of course, we don't have font here, but we're gonna need it. But font.header. I guess, what was it? Length, I think. Length was the number of glyphs that we had in our... hold on, let's just check this. Oops. PSFH. Yeah, so length was the number of glyphs that we have in our font. So if we are... this should be above, right? If we are above, maybe even or above or equal, the font length, then we should probably... We do not have this character in our map, so we should probably just set it as the null character. Right, so I guess here we'll need to pull this here. Oops. There we go. So now we have font defined. That's good. Just do this and right. So we handled the special characters. No, we still haven't handled them. We just did this. So this would need to move here, and I guess we could write this differently. We could be a bit more succinct with this. So we could do if this and this is less than font header, what was it, length? Yep. Then we do basically s, otherwise we do 0. Yeah, so we could write it that way. All right, so let's get rid of this. And also let me just put this up here. Nice. Okay, so let's go on now and actually do the check-in for special characters. So if c now is equal to so new line. So the only thing we need to do here is we need to set column to be 0, and we need to basically increment line to go to the next one, right? So line plus plus. Okay, so that's handle. Now, if we have so else if we have our character that is a tabulation tab, so now we would need to move our column by some number of characters, and here we will need to define something like this tab size. So for now, what I'll do is just go here and just add a define tab size, and let's say 4 so that we can see it. I'll go back and put this to 2 so that we can save on screen real estate space afterwards. But for now, we want to see that it's actually printing tabulations, so we'll leave it at 4. Right, so here in the general case, we basically just need to print the screen, print the character to the screen, and here we will need to basically grab what we did here. So yeah, I guess we are just gonna get rid of this method here. Yeah, I think we're just gonna inline it directly into the print method. So let's just get a few things that we need. Frame buffer. So we'll need this, right? So yeah, so we'll need those two, but we will have to move. So hold on. This one needs to go inside the else. So we have our character defined. This one here, the X would be the current column and the current line. So we would actually need these 2 lines to be inside the loop. And yeah, of course, this would be, so X is our column, right? And Y would be our line. There we go. Right, so we have our glyph, have pretty much everything that we need for now. So let's grab the rest of this. So current, yeah, okay, so we've grabbed that. So now we just need to do this, basically. So let's grab it. And go ahead and put it there. A bit of format in here. So current line, what is current line? How do we define this current line? Right, so this is the glyph line, yeah, we need that. And that would be somewhere here. There we go. So do we need anything else here? Okay, so we move on to the next character and then we move on to the next column also. That looks pretty okay, I guess. So let's go to our main and let's try to use that. Right, so let's get rid of all this and do let's do print, and here we need to give it a string hello world. There we go. Okay, so let's run that and see what we have. Let me just hit a save all, and then we can go here. Cool. So now we can go this way and can make this a tiny bit bigger. There we go. So let's just run this. Oh yeah, okay, I see. There we go. So we should have QEMU in our screen now, and we have our hello world. Great. So now let's try a few other things. Let's quit this. Let's go back to this thing here. So let's try to add some special characters. Okay. So let's do this. Let's do a few tabs. Actually, let's do a first tab and do hello tab. And then do this, and then we'll do something like this. Okay. Right, so let's save this. Let's go back to, yeah, first one. And make all. And run that. Okay, so it looks like it's actually working. That's great. So now we can move on to implement printf. Right, so let's go back here. Right, so let's go here, and I'll actually go here and change this to 2 because it's way too big at 4. Right, and I guess now we can get rid of this function. Okay, so printf, right? Printf is, I guess you could say, a pretty iconic function. So printf here, printf usually has the form const char star, which is the format, and then it has variadic arguments. So it takes a number of arguments, and this is what we're gonna have to deal with. So let's copy this, go all the way down, and let's just do this. Okay, so here we are going to need to do with variadic arguments. So let's take a quick look at how we can do that. Right, so here in the C standard library, we have this thing called a VA list, which is a variadic arguments list, which basically gets used by functions with a varying number of arguments, and also variant types, of course. And we have, I guess, 3 or 4 accompanying macros that gets used with this. First one is VA start. The second one is VA end, and the third one that we're gonna use is VA arg. So for VA start, it gets passed the VA list and the argument before. So basically, you need to pass it the argument that's before the variadic arguments. So in our case, in the So in our case, we will need to pass it the format so that it can calculate the offset on the stack of the variadic arguments. That's how it basically works. And so that's the VA start. I guess we could go into the detail of every one of these. Right, so VA start, it initializes the AP for subsequent use by VA args and VA end. VA arg basically takes an argument out of AP. And yeah, it basically consumes an argument from the list. And it takes as argument the AP and the type that you want to give it. Yep, there we go. So it takes the argument list, AP, and the type of the argument that you want to pop out of it. So you will have to know the type of the argument before you get it, because there is absolutely zero guarantee that you are not going to shoot yourself in the foot if you do something wrong. That's why we are going to use our format to let us know which type we want to extract. And of course, VA end is basically just to match the VA start to remove everything that was done by VA start and stuff like that. And I guess, and VA copy basically copies the list so that we can have multiple lists. And because, as we said, VA arg actually consumes arguments of the list. So if you want to have basically a reference to previous arguments, you need to copy the list. All right, so let's use these. Okay, so let's use these. So first of all, create a VA list. Just call it AP, which is the standard pretty much, and we'll call VA start. That will take AP and format, which is the last argument before the variadic arguments. Of course, we match this with a VA end. Of course, we pass it just AP, and here, what we need to do is so take the arguments that we have in AP and pass them into a function that would first of all take format and create a string with all the parameters substituted, right? So that's the first thing we need to do. And at the end of this, we'd have this string. And then here, we just do print the string to screen. And we already already know how to do this. We just call the method that we just created, print, on the string. And I'll just call this just call it stir buffer. And since we have no way to do dynamic allocations for now, what we are going to do is we are going to create it directly on the stack. So I'll create a char stir buffer, and here we need some sort of size. I'll just create what should I call it? Max buffer size should be all right. And this would basically mean that we have something on the stack here that gets basically this is the destination where we'll have our string with the parameters substituted. Substituted. There we go. Right, so here we need to call another function, and there's actually a function called printf, which also exists in the C library, which is basically the same as printf, but it takes a VA list instead of variadic arguments. So we'll implement that too. And yeah, you can see, so basically the LSP is giving us the definition that's in the C standard library. So we'll use that. So here we'll have a char, which is our buffer. And then we'll have the const char star, which is our format. And here the third thing would be the argument list, right? So maybe I should just remove these since we're not defining the function right now. Okay, so we have errors here because we haven't defined where these things are. Right, so let's just go here and probably go into this, and here we'll include stud arg, arg.h. So we will try to have as little dependency to the C standard library as possible, but we don't really want to re-implement this. It's easy to do, but it also takes a lot of time. So not really something that I'm interested in, especially since we've already done quite a bit of. We've looked at quite a bit of memory management, manual memory management when we did the assembly part. So now we're just going to try to streamline the process and see where we get. Right. So here, I guess we have just this. Oops, that's not what I want to do. There we go. So we like to also define this here, and let's define it as 512 for now. I guess that should be enough. And of course, this argument here should be stir buffer. Okay, so now we just need to define our VS printf function. So we'll define it up here, void VS printf, and it'll take a char star buffer, a const pointer to char, which is our format, and a VA list, which is AP. Note that we are passing the VA list as a parameter. We're not passing a pointer to it, which we could do. It's actually allowed, but we're not gonna need it for now. Okay, so let's do this, right? So first of all, we will need to know basically how long this format is, so that we can basically do a for loop on its length. So for that, we will need to create a function that computes the length of a string. So let's first of all, let's block in how we want to use it, and then we'll implement it. Right, so we want something that's utility2 format length, which should be equal to something like strlen of format. Right, so I guess this is a good time to introduce some new files. So let's create a string.h, and let's create a string.c, and we'll get here, and of course here we'll do if not def, and we'll call this string. There we go. And here we will want to define, so basically it returns utility2, and it's strlen. It takes a const char pointer, which is the string, and yeah, so let's do that for now. Yep, of course we'll need to include what do we call them? Types, I think. Yep. Is this the correct one? Yep, is. Cool. So we have that. So let's now go to here. And I guess the first thing we need to do is to include string.h. And I guess we could do utility2 strlen. Yep, that's, oops. What was it? Const char pointer stir. And this would be fairly simple. So we just return, I guess first thing we need to do is create our pointer. So char star s would be string, right? And we'll need utility2 length, should start at 0, and then while, so basically while s, so while s plus plus, length plus plus, right? And return length. Actually, it would be a good idea if I figure out how to add some unit tests in the library so that we can ensure that our functions work correctly. But for now, it should be fine. So let's move on. Right, so this one still complains that it doesn't know what this is. So let's go ahead and down include string.h, j, no, .h. All right. Okay, so now it's happy with this. Right, so we have our length of our the length of our format. So now we can just go ahead and do. So we'll get a I. It's usually 2. I guess we shouldn't need more than that. Yeah, we shouldn't need more than that, I think. So I usually 2, I is less than so format length and s plus I. And of course, here we are going to do, so as we know, printf basically takes formats of the type %sign f, %sign d, %sign u, %sign x, things like that, right? So first thing we need to do is, what is our format at I? Is it equal to %sign? There we go. Is it equal to %sign? Else, if it's not equal to %sign, then it's just a normal character, right? So we can just write it into our buffer directly. So here we can do buffer at some buffer index, right? Equals to format of I, and so we need to increment the buffer index after this. So I guess we could do something like this. Right, so this is the basic setup that we have. So if the format is equal to %sign, then what we need to do is we'll need to look at the next character next to the %sign and see what we have there. So let's do that. So first of all, we'll do I++, so that we can increment the index of the format, and actually we need to go ahead and create the buffer index, right? So utility2 buffer index equals to 0. Right, so here we have if, so I guess let's get the easy case out of the way first. So if the next, so format of I, if it's equal to a second %, right? That means that we just need to print the character percent into the buffer, right? So buffer at buffer buffer index plus plus is equal to just the character percent, right? So this is the very simple case. And here we'll get started with the, I guess, more common case, that I should call it. Format equals to, so if it is a string, I know how, actually, let's just block all the cases that we want to handle, right? So format of I is equal to, I guess the more common after a string is D, just, okay. And then we'll have something else for format I. That's equal to, I guess D is U32, or it's a 4 byte number. We could also go for longer numbers, 64 byte or 8 byte numbers. And here we can go for I equal to, oh, and basically this is not the C standard or POSIX printf. This is our printf. We're just going to implement some stuff that we are going to need for our debugging, and it will basically just be a quick and dirty printf that we use for just this part of the bootloader. And when we write our kernel, we're going to need to write a full-blown implementation of printf that basically matches the standard in some sort of way. Right, so U is for unsigned stuff. So format of I. So yeah, since we're doing these in pairs, let's do it like this. So capital U is for unsigned longs, and here we're gonna need, so what are we still missing? Okay, so yeah, we're missing hex, right? So we should do X, and probably even capital X. I don't know if that would be useful, but we'll add it. Oh yeah, and floating points, I guess, even though we are not gonna need them for now, but they're nice to have. So if this is equal to F, then we're gonna do something with it. Else, if the character that comes after the first percent is not one of these characters here, then we should probably just print it to the screen. But that means that what we did here for the percent sign is useless. Right, so let's get rid of this. We should probably just delete this and go here. There we go. And this would be useless. This would be useless. There we go. Okay. So I guess that's what we need to do. So now we just need to basically implement these things, right? Okay, so here we have a string, and we know that the argument in the list should also be a string. So let's, first of all, let's get the string, the argument. And here what I'm going to do is I'm going to, so here we have a few types, right? We have strings, we have integers, we have longs, we have unsigned ints, unsigned longs, and these are basically unsigned ints and unsigned longs. And here we have doubles, right? So let's create all of these here. So first of all would be a car pointer, should be let's call it strarg, right? We need i32, which is the int arg. We need a u32, which is uint arg, and we need a i64, should be the yeah, let's call it long arg, and u64, let's call it ulong arg. The hardest parts of programming is figuring out good variable names. Right, so let's get to this. So first of all, strarg here, we would want to extract the argument from the list. So we'll use varargs. So of course, we'll cast it to car, and we'll do vararg, and it'll take AP and the type, and of course the type is car star, right? Right, so we have our string argument. So now we'll need to know how long this string argument is so that we can basically copy it into the buffer. So let's see, maybe I should go here and do u32 string r length. Just define it that way. And here we can do something like this and do string arg length is equal to, of course, we already have a strlen function, and we can use it here for string arg, right? Okay, so now we have the length of the function, so we need to copy it basically to the output buffer. So here we will need something like some sort of memcopy that basically takes the destination, which is buffer plus so buffer index, right? So we have, yeah, we are basically, buffer index points to the index that's still not filled yet, so we can just use it here as the argument. There will be no off by one error. And here we have the source, which is the argument string, call it string argument actually, and the length is the strarg length. And of course, we don't have a memcopy, so we'll have the privilege to go and implement it. So here I'll just put it into string.h for now, but yeah, it should be fine. Right, so memcopy takes, so what does it take? It takes a car, or actually let's write the generic version. So it takes a void pointer, which is the destination, and it takes a const void pointer, which would be the source, and then it takes a u32, which would be the length. Right, so let's go to here and do void memcopy. There we go. Whoops, there we go. All right. Right, so for memcopy, I guess there are a few ways to implement this. The naive way would be to copy bytes from source to the destination, and you'd probably have n bytes to copy or len bytes to copy, and so you would do the actual copy operation n times. But I think we can do a bit better than that, right? So here we are currently in protected mode. We are in 32-bit mode. So the largest register that we have access to is 4 bytes wide. So what we need to do is actually use that fact that we can use full registers of 4 bytes to speed up the copy. So instead of doing the copy len times, we could do it len over 4 times plus 1, 2, or 3 iterations. So basically, we have two cases here. We have len is equal to 4k, with k some natural number. But this means that k is a multiple of 4, 4 being, of course, the... maybe I should do this. There we go. So k is size of utility 2k, which means that len is a multiple of this utility 2. And the other case is k is actually this k plus 1 or plus 2 or plus 3. So these are the 3 possible remainders that happen when we do division by 4. Right? We cannot have plus 4 or plus 5 because plus 4 is basically just 0. And we go back to this case. Right, so what we need to do now is we need to handle as much as we can from this first case. And this would speed up the copy by, I guess, 4 times, theoretically, of course. And here we need just to handle the remaining 2 or 3 bytes that need to be copied individually. So let's do that. So for let's create an I, set it to 0, and do I is less than length divided by size of utility 2, and there we go. So here we have this I here, that's our pointer. So what we need to do is we need to coerce the compiler to think of our source and destination pointers as utility pointers. So let's do that. So utility pointer of D, right? And this would go this way, and we'll tell it that the ith, actually, the ith item of this would need to be utility pointer of the ith item of S. And these being utility pointers indexed by I, it means that they will index every 4 bytes or length of utility 2, which is exactly what we wanted to speed up our copy. And here we need to know which was the last offset that we've copied. Yeah, so let's not do the work again by just storing the storing I here. I guess we can do that. Right, so here last offset equals I multiplied by 4, right? So this is basically the last item that we could copy that could fit into this size of utility 2 multiplied by k. And here we know that we have 1, 2, or 3 iterations that we need to do. So let's do for I guess for I equals 0, let's reuse it since we don't really need it anymore. So I is less than length, should do this, length mod size of utility 2, and then do, it should be fine, I think. So here we're going from I0 to basically the remainder, which is 1, 2, or 3. And we are going to use, so basically D of last offset is equal to S of last offset. And here we just treating them as as byte pointers, right? So here we'll do this just for clarity. We'll add these two. There we go. So this would be U8 pointer, and this would be D. There we go. Right, so here U8 is, so D is dist, right? And I'll just, for completion's sake, I'll tell it that it's a U8 pointer. And here U8 pointer S is U8 pointer source, of course. So here we have S and D, and now we don't really need this anymore, do we? So let's get rid of that. Let's get rid of that also. Yeah, that's fine. So last thing we need to do here is just do rest of C++. And that should be our memcopy done. So let me just remove these two here. Yeah, but that should be fine. Right, so if we go back here, does it take memcopy from string? Yep, that's good. That's great. Okay, so here we have our memcopy from string. And that means that here we have pretty much finished this. We just need to basically move the buffer index by the string argument length. Right. Now the question here is, oh no, never mind. So the zero byte of this string argument here was actually discarded by the string length, since we're just copying the length of the actual characters. So that should be fine. So now let's go to D here. Right, so what do we want to do here? We have D, which is the int argument, and we'll do pretty much the same thing again. So varg takes AP, and we tell it that it's a i32 that we want. And I guess, actually we've missed a case. We haven't handled the characters. So else if format of I is equal to C. Yep, haven't handled this case, which is a pretty simple case actually. So buffer at buffer index should be just basically equal to U8 or cast of U8 of the VA args that takes AP and takes char as an argument. And of course, we need to increment buffer index. After this, yep, it's missing the thing. Right, so let's go back to ints. So here we have our int, VA args. So we need to cast it to an int. Actually, there's no need to do stuff like this. Right, so now that we have an int, we will need a way to convert the int representation into its string representation, right? So here what we want to do is create a function. Let's call it int to I2A, which is basically the standard function that does this in the C standard, I2A. And this function here will take So what should we pass it? Should probably pass it the int argument, and we should pass it the buffer to which it should write, which would be in our case. So the same thing we did for memcopy, buffer index, something like this. And this I to A should return the length that it written to the string length that it has written to our buffer, basically to the buffer we've passed it. So we can do buffer index plus equal this. Yeah, that looks pretty good. So let's write the I to A function. We'll go to string. Here we do u32. Call it I to A. And what did I say it takes? It takes a u32. Actually say it takes a an I64. Okay, so we can reuse it for pretty much all the other conversions that we need to do. So I64 and call this D. Let's call it value, and here we'll have a char pointer which is buffer, and I think that's pretty much what we need. Right, so let's go here and do u32 I to A. There we go. Right. So let's write this. Right. So let's write I to A. I guess let's get rid of the obvious cases first. So if val is 0, then we basically just need to write buffer 0 is just the character 0, right? And yeah, we need to print a termination string, because if we forget it, we have broken our buffer. So yeah, let's write down. This would be the actual 0 character, and of course we return. We've written one character, so we return 1. Right. So here, what we need to do next is handle the negative values, right? So if value is less than 0, we're gonna actually So what we're gonna do here is we're gonna do u32 index equals to 0. Here we're gonna do value basically is equals to negative value. But before that, I guess we need to, let's ensure that we have written the negative sign to the buffer. So we'll write this to the buffer. And we'll set our index to 1, because we basically we want to start from index 1 when we write the actual characters that form the number. Right, so here we get to the bulk of this. So let's do a for loop. Do we want a for loop? Let's do a while loop. So while value is larger than 0, and here of course we need to increment our I call it index for some reason. Right, so here we want to increment index. So while value is larger than 0, we go ahead and just do buffer at index is equal to, so basically we want to take the next character between 0 and 9 and put it into our buffer. So that means that we'll do something like 0 plus the value mod 10, right? Yep, that looks like that looks correct to me. And then of course we need to divide the value by 10 so that we scale it down. And here you notice that what we're doing is wrong technically, because what we're doing is if we take 1, 2, 3, right, which is our value. Let's set this up. Value equals 1, 2, 3. So here at every iteration of the loop, what we're doing is we're taking val mod 10 here equals to 3, right? So we're taking character 0 plus 3, which is equal to character 3, char 3, and that means that we are putting the third character inside our buffer. So let's do something like this, right? So this is the first iteration, and of course we are also doing val scaling it by 10, which basically means that val now equals to 12, right? So let's repeat this here. So val mod 10 gives us 2. We're doing 0 plus 2, which is equal to character 2, and then we have this buffer, which already had 3, and now we're adding 2 into it, right? And we're going ahead. Let's just add a bit of space here and doing the scaling by 10. That means that now value, our val is equal to 1. And that means that here we'll do, again, the 10 modulo. And here we'll get 0 plus 1, which is character 1. And of course here we'll get 3, 2, and then 1, right? And we finish because the next value would be less than 0 or equal to 0. So here you see where the issue is. The issue is that we are writing the characters in reverse order, because that's how we can get to them. The alternative to this is to figure out how big our number, or the largest power of 10 that basically covers our number that's above it, just right above it. But that means that we need to do an extra loop just to figure that out. So what we are going to do after this is we are going to need to flip these numbers around, right? So we need to swap 1 and 3 to get the correct result. So that's what we're going to do here. So at the end, swap numbers around the buffer's axis, if we can say that. So basically, the axis of the buffer is 2, which is the I guess the center of the median of the buffer, and we'll swap all the elements around that median. So that's what we're gonna do next. So here we have all our buffer written. So first of all, what we need to do is we need to ensure that our buffer actually is terminated. Otherwise, we'll get some weird results. Right, and now we can do, so let's see. Yeah, so now we need to reverse our buffer, but there is a small thing that we need to take into account, and that is this minus sign that we've written here. If we have a minus sign in the buffer, that means that we want to start from the index that's next to it, basically, from index 1. Yeah, so let's do that. So if buffer 0 is equal to character minus, yep, so we want to be doing the swapping from 0, or sorry, from 1, else here we do the swapping from 0, right? And of course here we have our index, which is the length that we have written. So we should return index. So now let's figure out how to do this swapping. And I guess the easiest way to do this is to just create a new method here. Call it stir reverse, something like this. So this would take a char pointer to some string, and it would reverse it. But before that, let me just add it here, somewhere here. So stir reverse takes the a pointer to a string. Yeah, so I've put it here because we might want to use it afterwards. Right, so let's do this. So what we want to do here is basically just loop over this, and we'll... Okay, so first of all, I guess we need to figure out how long this string is, right? So usually stir length equals stir length of stir. There we go. So now that we have the stir length, we need to do the loop over half of stir length. So basically, we are going to swap elements that are symmetrical across the median of the buffer of the string. And what we need to do now is basically just do u8 temp will copy string I, and then we'll put string I, or we'll put string, so length, right? This is the end, or should I say length minus 1 is the end, and then we remove I elements from that. There we go. And then here we put a string length minus 1 minus I. We'll put tmp. So basically, we're just swapping the elements across this the median, the middle of the string. Right, so it's as easy as that, and now we should just call it. So let's just do this, and here we'll call string reverse with so here we've said that we want to give it the buffer from 1. So what we need to do is basically give it buffer plus 1. Right. And here we want to do the same thing, but with just buffer. String rev, and just give it buffer. There we go. And that's it, I guess. That should be it. All right, let me just get rid of all these. There we go. Cool. Cool. So now let's go back here. Right, so here we have iterate with the integer argument. So we need to go on and implement this for all the other arguments. So here, capital D is for long signed integers. So this would be our long arg, which would be, yeah, why did I use int there? Actually, let's just use our types everywhere. Let's just use our types everywhere. Right, we should also use them here. U8 and U8. Okay, do we have some things? Yeah, probably this U8. What's going on here? Conflicting types for print. Oh, I see. Yeah. Okay. So U8, and of course this would need to be U8. Since we're not really trying to conform to, I guess, POSIX or C or whatever, so we can do whatever we want with our signatures. Right. So here, let's just go to string and do the same things. So we have quite a few chars, so let's do there we go. And do we need to substitute something else? I guess not. Okay. So let's do the same thing here. There we go. Is there something else that we need to do? Oh, looks clean. Right, so let's just save those. There we go. So let's just get rid of this. Nice. Okay, so let's get back to this. Okay, so here we want this to be a I64, and we are going to call vararg with AP and I64 as our argument. And here we'll pretty much do the same thing. So buffer index incremented by I2A, and I2A take the value, which is our long argument, right? And it takes the buffer, which is our buffer, plus the buffer index. I think that should be about it. Yep, looks pretty good. Looks pretty good. So now let me just yank this into here. And here what we need to do is change these into U, right? And change this argument here into, I guess U end. Yeah, we call that U end. So let's do this. So long becomes U end. There we go. Okay, looks good. Oh, okay, maybe not that good. So let's paste this here, and we'll do the same thing again. And this time becomes U long. Oh, yep, nice. So U end becomes U long, and here, so what do I need to do? Yep, I see it. So here we want U64 to become U32. There we go. Okay, so this and this are done, basically. So now we need to just handle this hex format, I guess, and the decimal stuff also. Oh, and here I haven't changed this, so let's probably do that. So this would be format of I. There we go. Right. Okay, so let's do the hex. So basically for hex, we're gonna need to do basically the same thing. So here we know that this is a int. Since we don't really care what type it is, hex values don't have negative values. So let's just put it into our uint argument. And this here would be pretty much the same thing we did before. So u32 yeah, so va arg takes ap and u32. And here we do pretty much the same thing, except that instead of converting this to a base 10 number, we'd want to do something like I2H, which basically would take uint arg and of course buffer plus buffer index. And this uint h, instead of doing the division by 10 to get base 10 numbers, it would do the division by 16, and it would also handle the case where numbers above 10 need to be converted to A, B, C, D up to F, right, between 10 and 15. So let's do that. Actually, before we do that, let me just do this, like this here, and do something like this. And since we'll pretty much use the same code between the two, so let's just make it easier. So here uint would go to ulong. Just hit it with that. And here, what we want, u32 would go to u64. There we go. Right, so let's implement I2H. Right, so u32 I2H, and this one here takes a 64-bit value and a pointer to a char buffer, and that's it. So let's do this. U32 I2H. Yes, thank you. There we go. Actually, now that I think about this, it really doesn't make sense to call this I2H. Integer to hex is not what we want. What we want is hex to string, which is should be H2A, I guess. So let's see. This would be H2A. Yeah, so let's do this here too, and H2A. Yep, cool. So here what I'm gonna do is I'm gonna make this easier by not handling the possible negative values. Yeah, I'm gonna do that. I'm gonna do that choice. I don't know if we're gonna ever need to print negative hex values, but we should print them as positive, just chorus them and print them. It shouldn't make that much difference, I think. So yeah, we'll pretty much do the exact same thing that we've done already with the I2A. So if value is 0, then we just write 0. So buffer 0 would be so 0, and then buffer 1 will terminate the string. Oops, buffer 1. Come on, there we go. Terminate the string, and then we return the number of bytes we've written, which is 1, and then otherwise we'll just go ahead and do a for loop, and I guess we could just use a utility2 int equals to 0, I less than yeah, actually we don't need an I. Yeah, let's do the same thing we did before. Let's do just a while loop. While value is above 0, here we declare an index should be 0. Come on. And what we'll do is basically buffer. Let's create U64. No, it shouldn't be 64. U32. Actually, you can just have a U16. Let me think about this. No. We just need a U8. We'll have values between 0 and 16, so just need a U8. So this would be our, what should I call this? So remainder, right? Let's, actually we don't need to initialize it here. So first thing we need to do here is set our remainder to value mod 16 this time. And here we need to handle the case where remainder is larger or equal to 10. Yeah, so in this case here we need buffer to have, so buffer at index would need to be character A plus whatever the remainder is. Oops, that's not what we want. That is not what we want. So this would be remainder, and of course what we need to do is there we go. So here we need remainder minus 10 because the A basically encodes the 10 already. So here else, yeah, so basically else we're gonna do the same thing that we did before. So this means buffer index is equal to just the character 0 plus remainder. There we go. That should be good. And of course, at the end of this, we need value to get scaled by 16. There we go. And of course, we need to increment our index when we use it, which is pretty much the same thing that we did before. So now we just need to terminate our buffer. So buffer at index equals to the null character, and then we need to string reverse our buffer. Since we're not handling negatives, there will be no special handler for those either. So here we just need to return index, and that should be pretty much everything that we need. Just format a bit, save this, actually save everything, and go back to console here. Right, so we just need this to be implemented. So for now, I'm just gonna ignore it since we are not gonna use it. But I'll write to do implement this. Right. So I guess we have our printf. So let's see here. Yeah, we don't really care about those. Um, all right. Right, so I guess this here needs do we need this to be non-const? I don't think so, so we can just use const here. Oh no, actually never mind. Yeah, this one is not const. Okay, well, we should be okay. All right. So let's get this compiled and see what we get. Okay, so we have quite a few warnings here. Let's go through them. Okay. So I guess we just pretty much need to just replace this with this, and we should be okay. Oops. Right. And I guess this needs to be replaced too. Okay. And what did we have here in print? So let's just replace this too. And where did we define C? There we go. So this would be this. Good. Okay, so let's see what we have here. Conflicting types, yes, of course. So let's go back here and change this to. So that should resolve that. Okay. Let's see if it's okay. Right, so here we need to force the conversion. Here we are passing it constituate to a, oh, okay. So let's go back, I guess, to string. Yeah. So let's just change all the U8s to I8, just so that it's happy. I'll do the same thing here. Actually, this one here, I still want to keep as a U8. Let's see. Okay. Right, and there was something else that we need to do here, which was oh yeah, it was here in print. So we actually wanted to do something like U8 and U8. There we go. That should be fine. So let's try this again. Okay. So what do we have here? We have second argument. Okay. Yeah, so it's gonna promote to in. We don't really care about that. And s equals stir, initializing with expression const 8 at string.c. Okay. So let's go back, string.c. Right, so we have, okay, so we can just make this. I guess we can just strip the constness by forcing it a bit. Shouldn't matter, since we know what we're doing here. Let's go back. Okay, so we just have that one warning that tells us that the I8 can be promoted to end. And of course, we have the major issue, which is undefined reference to mod div 3 and div di3. So we'll get into these in a bit. But I guess this should be fine for now. We can just ignore this this warning here. The main issue that we have here is that we are missing these references to mod di3 and div di3, and what these two functions do is they define how to do basically mod operations and division operations on larger register sizes. So basically, since we have, so if we go back to code here, since we are using i64 for our value, and our compiler compiles in 32-bit mode, it doesn't know how to do division on 64-bit values, especially the modulo and the division that we are doing here. And it's asking for these two methods called divdi3 and moddi3, which basically tell it how to do the division in software instead of doing it on the CPU and hardware. So for now, we have two choices. The easier choice is to just put this to i32 for now and just handle integer values, which should suffice for us. And the other choice that we could have is to actually go ahead and implement those methods. But we do not really want to do that now. Yeah, I don't think that's something that's very interesting for now. And it also is quite a bit complicated since we will need to do a lot of binary math. So for now, let's just get rid of the 64-bit values and see what we get. Right, so let's do this. And now if we go, right, so we are building. Cool. So let's, hold on. Do we actually change our main code? Yep, we did not. So let's do that. So we can leave the print there and we can just add a printf. So what do we need to do here? Let's do something like 2 plus 2 equals, let's do something like this, and then let's do something like this. That should be nice. Of course, let's just add this there. Cool. All right, let's rebuild this. All right. All right. Okay, so let's hit continue on this. And what do we have? We have 2 plus 2 is 4 and some garbage. Means that we have some issue. I think we are doing some. We are copying memory after the allowed limit. So let's try to see where the issue is. Right. So. So stir buffer, or maybe is it that we are not correctly terminating our strings? Let's try to see here. And of course, we might also want to just comment out these longer formats since we're not handling them. Yeah, let's just comment these out. This one and this one. And the on this one. Right. Okay. So let's see now. And here we keep going. Yeah, I feel like we're missing some terminations somewhere. Yeah, so it feels like it's a sort of termination problem. So let's just let's add that to our buffer. So buffer at buffer index, we'll just set it to 0. And I guess I'd like to change this to return the length that we've written into the buffer. It's always nice to have. So let's just change this to U32, right? And we'll need to also change it. No, we don't. Okay. We don't. Okay, cool. So here we are printing our buffer, and let's just go to print here. Do we handle termination? Yes, we have a while that handles termination. So let's compile this again and see if that solved our issue. So let me just go ahead and check that we have no new warnings. Unused variables, yeah, of course. So let's just go and get rid of those. So this one and this one should be the unused variables. And I guess we could get rid of this thing here, but just telling it that this argument here is an i32. Sorry, the warning that we have. So let's do that. And let's rebuild again. This time we should have 0 warnings. Yep, we have 0 warnings. Great. Okay, so let's go this time. Continue, and as we can see, this time we have no garbage, so it means that we are stopping where we should stop. And now we have a working printf. Let's do a few more tests on our printfs to see where we have issues. So let's printf a few other things. Right, so let's see here. Let's see, hello, %s, and of course the line. And here we do world. This is a long line. Okay, so that's for the S format, and here we'll do my pointer address is, and we'll do 0x percent x, and here we'll give it something like what should we do? Let's create user2 a equals 1 2 3 4 5, right? And we'll do, and my value is something like this, right? Oops. There we go. So here we give it the address of A, and then we should give it A as the value. And this is basically a test for multiple arguments. Of course, we should not forget to do this, and we should not forget to do this. Okay, so let's save that. Let's build it and see what we get. Okay, do we have... No, we don't have any warnings. So let's just go ahead and run this. So I don't know if this looks right. So here we have an issue because the address is not printed correctly. So 7 something 8, and the value is 1 2 3 4 5. I guess the value is okay. It's the address that's not getting printed correctly. So why is that? So let's go into our printf and see what we're doing with this address here. So I guess the issue would be in H2A. So while the value here we have, okay, if it's above 10. Oh, right. Yep, small mistake. But yeah, all right. Let's rebuild this. There we go, and see what we have here. Oh, okay, so it's much better now. Let me just zoom in a few times here. Yep, so the address is actually printing correctly, and we have the value. So I guess now we have a working printf, so we can use it for the rest of our development. And we are going to need it because we are going to start working on pretty complex stuff. I guess the only thing that I'm noticing here is that the hello world is actually starting on the 0th pixel, but the other lines are not. So for some reason we are actually skipping 1 pixel before we are writing. And I have no idea what that is. So let's see if we can find out why. This shouldn't be here. This should probably be somewhere inside VS-Print. Right. Actually, it could also be inside just print. So let's see what we're doing here. We're in column to 0, and we're incrementing line. Okay. Oh, right. So when we have a new line here, we set the column to 0, but since we are still in the loop, we basically go down here and do column plus plus, which basically sets us always at column 1 when we do a new line. So what do we need to do here? I guess what we could do is we could increment s inside this branch here and do a continue to basically go back to the top of the loop. Or we could set column to negative value, but we have it set as a U32, and I don't really want to do that. And I guess we should also have the same issue here on tab, because tab size is effectively 3 now because we are doing this plus plus here at the end. Right, so let's do that. Let's just do s plus plus and continue here. There we go. And here we should pretty much do the same thing and continue. There we go. Let's see if this solves our minor issue. Okay, so that builds. Let's run it. Okay, so I guess that solves our issue. Yeah, that was it. Now we have all the lines starting on the correct offset. Cool. All right, guys, that was it for today. We have implemented a subset of printf, and we have printed the strings to screen. There are a few things that are missing from our implementation, namely, for example, when we reach the end of the screen of our frame buffer, we haven't put in place any way to detect that, and we have no way to basically scroll the screen for now. But we're not expecting to print that much text for now. When we work on our actual kernel, we will do a lot of cool stuff. We'll do double buffering, we'll do scrolling text graphics and stuff like that. So we'll leave that for then. So I guess that's pretty much it for today. As always, if you have any questions or comments, I'll leave them down below. And if you like this series and you want to show your support, you know what to do. See ya. Bye.